In this video, I'll try to explain the relationship between the test and the disease. First of all, we group patients into those with a disease, who are sick, and those who are healthy. Okay, the people without disease. Then we group the test results into those with a positive test result and those with a negative test result. Okay, we actually have four possibilities. We can have a true positive effect, that is a patient with a disease and the test says he's got the disease. He has a true positive disease. We can also have a false negative test result. That is a patient with a disease, but the test is a poor test. It says he doesn't have the disease. Okay, so he has a false negative test result. Similarly, if you're healthy, you haven't got the disease, you can still have a test, and if the test comes out and says you got the disease, okay, it's false positive. The test says you're having a disease which you actually don't. Then of course, in most cases when you're healthy, you take the test and it says you're healthy. Fine, the test is negative, you're healthy, it's a true negative test. We use this table, this 4-cell table, to calculate sensitivity and specificity of a test. Sensitivity is the proportion of sick people who are actually identified through a test. The proportion of illness which is catched, which is caught by the test. Okay, so let's say here we have 5 people here who are sick. Our test manages to identify 4 of these. So we have a sensitivity of 4 out of 5, 80%. The test has a sensitivity of 80%. However, most people do not go around with a disease. Most people are healthy. So if we just test the whole population, most of these will be healthy. They will not have the disease. And then the question is, okay, so what is the proportion of those who are healthy, who are identified as healthy by the test? That means having a negative test result. What we want is, we want the test to identify, to put all the healthy people down here saying they have a negative test. Unfortunately, the test doesn't always do that. Sometimes it says, in someone who's healthy, you have the disease, you're positive, okay? The specificity is the proportion of healthy people having a negative effect. The proportion of healthy people having a negative effect. That is 443 out of 447, the sum here. That is 99%. So these values, quite good. You have a sensitivity, the proportion of individuals with a disease who have a positive result. Specificity, the proportion of individuals who are healthy having a negative test result. Now we'll introduce 2 other concepts which are very important for you as a clinician, and that is, what do I do when I have a test result already? It's not that I have a patient in front of me, I have the test result, and it says positive, negative. What do I tell the patient? We'll use the same figures to illustrate PPV, which is called positive predictive value, and NPV, which is negative predictive value. The positive predictive value here is actually, if I have a positive test, what proportion of those individuals actually have the disease? Let's first look at how many positives do I have by the test? 4 and 4. I have 8 positive individuals. How many of these are sick? 4. So the positive predictive value is 4 out of 8. That's 50%. So if someone just gives me a test result, says it's positive, half of the patients, half of those having this test result will actually have the disease. If instead I have a negative test result, I have 444 individuals with a negative test result. You can see huge numbers are over here. They're actually true negative, but there is 1 false positive. So the negative predictive value is 443 out of 444, 99.8%. That is actually, for instance, the case with celiac disease testing. It's almost as high. if you have a negative result, you can be almost sure that the patient doesn't have celiac disease. However, if you have a positive celiac disease serology, you can't be sure the patient really has celiac disease. Thank you.